pattern here is that all of my evidence, all of my observations did not come from NASA, did they? I did not once go to NASA, SpaceX, Blue Origin, ULA, Boeing, or Sierra Nevada Corporation. I didn't go to any of them. For this debate, they can all get fucked. This debate is simply based on what I have observed, the mathematics that I have done, and the conclusions that I have come to based on those observations. And as you said quite elegantly, you see no reason to believe that you're on a ball. Well, fine. Based on the observations that flat earthers have told me to do, I see absolutely nothing pointing me to the claim that the earth is flat actually being true. I see everything pointing to the fact that there actually is curvature, that it is measurable, that you can see it if you would go out and actually take a good look and also not bury your face in the sand. And also, if you actually do the observations properly, do the math properly, you can come to the same conclusions I do.
Okay, and we have a couple questions from the live feed, if we can jump into those real quick.
Sure
this question
thing.
I'll ask to both of you, and would you please frame the answer with respect to your own model? I will ask Nathan first. First question is, how do you explain sunrise and sunset on a flat Earth model? And if you have a model that can actually do this, is something you can point. We'll put in the video description afterwards.
Yeah, the sun sets and rises because of perspective. We can't see forever. The sun is small and localized, and the Earth is large. So,
I'm not sure if that actually answers the question.
Why we have sunsets?
Correct. If you have a flat Earth model, can you?
So the Earth is flat and the sun is going away from you. We can't see forever, so the sun disappears. It's perspective.
So, okay, let me try to reframe this. Why? Because I'm trying to get it in the way that it was probably intended to be asked. Why on a flat Earth model do we see the sun actually go below the horizon?
Because it's really far away. The laws of perspective. I don't understand.
All right, let me ask Reg the same question. Can you frame it in the way from a ball Earth or spherical Earth we read Reds, and at the same time, if you wish, explain would it work on a flat Earth, or what is he trying to say here as far as the perspective aspect?
Okay, so let me just make sure I understand. You want me to explain what the flat earther is trying to say, or do you just want me to explain why sun actually set on a round Earth?
Yeah, both. Why we have sunrise and sunset on a round Earth really quick, and then maybe parse out what he was trying to say as far as perspective on a flat Earth model?
Well, quite honestly, I can't do the second one because I honestly think he might have a different definition of perspective than I do that has different consequences. So he's going to have to explain that one in a better way. But as far as my model goes, the reason why we have sunrises and sunsets is because the Earth is curved. The sun can only illuminate one half of that curve, at a time, being that it's a sphere. And so as you come into to light, that would be sunrise. As you're dipping out of the light, that would be sunset. And again, so you have half of the Earth in darkness, half of the Earth in daylight. I can show up a diagram, which would probably help a lot of people, although I don't know why I should have to do that. But if you want to, I can. But yes, the reason why we have sunrise and sunset is because we have a round Earth. Light can only illuminate half of that planet at a time. There is a terminator line, and that terminator line gives us the sunrises on one side and the sunsets on the other.
I think it's a fair question to be asked about the nomenclature you're using here, Nathan. You said the word perspective, and I think for clarity's sake, can we kind of narrow down what your meaning of the word perspective is as far as the word usage as you're using it in your argument?
Yeah, so as things move away from you, they become harder to see, and they also, if they're in the air, they come closer and closer to the horizon, and there comes a point with the lines of convergence that you can't see anymore. And so the reason that the sun sets is it's really far away. I don't know
Would that not change the angular diameter of the sun as it recedes from us?
I went over that. I'll go over it one more time because it's well known that when a light of any kind shines through a dense medium, it appears larger. So not only does it's not staying the same size, it's getting bigger, but you want to get rid of that. Just increase your altitude, decrease your atmospheric refraction or atmospheric magnification, whatever Reds wants to call it. But sunsets. Okay, take a look at a yin and a yang symbol. It's the most vague flat Earth map you could ever look at, but we all grew up with it. We all know what a yin and a yang symbol is. The sun and the moon are rotating around polar center, and the reason we have seasons and sun analemma and 24-hour days in the north is because the sun's path is expanding and contracting annually, alternating every 6 months. And so, I mean, that's
real quick,
sunsets for
Reg,
you.
do you want to
Steve.
address that? Yes. Okay. Go ahead, Kyle.
I can address that only if the question is to address it. Or like, how do you address that? So is that what you want to do? Because I don't want to step on his toes.
Well, real quick, I mean, he's actually advocating the position that if the sun is moving away from you, it should change the angular diameter. Your argument is that we don't see an observation of angular size change, and that it actually does go below the horizon rather than just a receding point or a vanishing point. Is that correct?
Correct. Basically, the law of perspective is a mathematical equation. And basically, without saying it one more time, all it means is that if an object is close to you, it's going to appear at one size in your vision. As it moves away from you, it's going to get smaller in your vision as it goes away. Eventually, it's going to be so small that the available resolution of your eye will be insufficient to make out whatever the fuck it actually is. Now, the law of perspective is for the object in totality. That is the thing that I disagree with a lot of flat earthers on. Perspective, or the actual law of perspective, says nothing about objects disappearing bottom up. It says absolutely nothing about it. And so, if perspective was the reason that the sun goes away at night, what we would expect to see is the sun shrinking and shrinking and shrinking and shrinking and shrinking to a freaking pinpoint, and then eventually the resolution of our eye be insufficient to actually pick it up again, and then come back into view again when it gets larger and larger and larger in our vision again, because it's getting closer again. In fact, what we actually see is that the angular size of the sun stays the exact same throughout the entire day, yet still sets, which means that the one thing that's causing sunrises and sunsets is actually not the law of perspective, because the law of perspective, being an observable phenomenon, is not being observed when we observe the sun, as I have demonstrated earlier in this debate.
All right. Kyle, did you want to add to that?
I was just going to say something before you moved on to the next
Sure.
question. While everyone's listening, tomorrow night at 7:00, we are featuring another debate, and that will be between G-Man and Pamela Whistle from the American Atheists. She will be coming to rebut G-Man's claim for years now that atheists do not exist. So join us tomorrow at 7 for that debate. And now, Steve, back to the questions.
All right, thank you very much. So there's a few questions in the live chat, but they're kind of I don't want to ask them directly. They're kind of framed a little bit odd. But how about do you want to ask each other questions? If you have questions of your own, Reds, towards Nathan.
Yeah, I got some questions for Red still.
All right, why don't you ask your first question, and Reds can ask you a direct question of his choice.
Yeah, Reds. Since they're trying to be so fair to all the continents, I found it interesting they excluded Antarctica, one of the entire continents, from the map. But that's not my question, Reds. I'm just wondering, on your model, how do you explain the moon being cold light, putrefying light, also having a blue color, blue hue to it, and the sun having a whitish yellow hue, giving off a hot light and being preserving, which is the opposite of putrefying? How do you guys explain that on the globe model?
I'm going to need to ask you to clarify that question. What do you mean by cold light?
You've never heard of cold moonlight, Red?
I've heard of people messing up observations when they're trying to measure the temperature of the moon, but I want to know what you're referring to specifically.
So the moon, the light is putrefying. You can test that with meat or vegetables. It has the opposite effect that the sun has on meat and vegetables, which is preserving. It's how we make beef jerky is with the sun. You can't make beef jerky with the moonlight. It's an opposite kind of light. It actually causes all food to decay, which I think is actually part of the brilliant cycle of life God created. But what I'm saying, Red, is that moonlight is measurably cold. The shade will be warmer than the exposed moonlight. I've done my own test on a supermoon last year, and noticed a temperature variation of 6 to 8 degrees between the moonlight and the shade. And I'm just wondering how the sunlight is getting bounced off the moon in your model and magically turning into a cold light source that's blue and putrefying.
I'm going to say I don't have an explanation for that because I assert that it doesn't actually happen. So you're asking me to prove something that I don't think actually happens.
Okay, can you pull up my test on the supermoon?
I won't be able to do that. Someone else can.
I'm not on a computer. I thought you were on YouTube earlier. But all right, well, maybe later, Red, you can go check it out. There's not just me, but there's hundreds of people doing a laser thermometer test. You can get one for $20. It's a lot cheaper than your P900. So just go ahead, grab one, and test the moonlight, and go ahead and figure out what's going on there. Maybe I messed up my experiment. But pretty sure moonlight's cold. So
okay. Well, hang on one second. Let me do this real quick. All right, open up the drawer. What is this? Laser thermometer. Let's see. All right, let's go ahead and point this at the wall. The wall is about 6 feet away. All right, I'm getting 75.4 degrees. Now let me move it to my closet, which is a lot further away. 32.2 degrees. Wait a minute, let me look at the instructions here. Distance from the point from the surface you're actually measuring actually plays a role. Otherwise,
I don't point the laser at the moon, Red. I point the laser at the ground.
Temperature of the object. Okay, thank you. I'll be sure to look into that test you did later on.
Cool, good stuff.
So, if I could, for the audience sake, who may not know about quote cold moonlight, you're saying that the light energy that's being from the moon as a source or something along those lines, the photons actually reduce an overall temperature or kinetic energy?
Yeah, and since I'm going to assume you got really intelligent listeners, guys, I'm trying to figure this out because we can't send a cold light. Light or heat moves from hot to cold. Pretty much everyone knows that. So what I think's happening is the sun is giving off its heat, and the moon is actually sucking that heat up. And so that causes the light from the moon to give off a cold moonlight. That's just my theory on how it's all working. But yes, moonlight, and this has been done by hundreds and thousands of researchers, especially in my group, can all confirm that laser tests, and Red, we're not shining the laser at the moon and then shining at the ground. We're shining at the ground where the moonlight's hitting, and we're shining at the ground where the shade's hitting. And I'm not doing the test from super far away where the moonlight is. I'm just standing on top of the ground, pointing down at the ground, and then I go stand on top of the shade and point down at the shade. I welcome any of your listeners. This, for me, threw the entire heliocentric model on its head. Because on the heliocentric model, if moonlight is sunlight, moonlight cannot be cold.
All right, so you're saying because, of course, heat is, by definition, the transfer of thermal energy from a higher concentration to a lower concentration. You're saying that the moon not only acts as a thermal sink, but actually re-radiates it colder than the initial heat going in? So how is it radiating negative heat? I want to make sure we're not trying to straw man you.
It's pulling heat. Yeah, it's pulling heat somehow. So it's like a generator of some type. And I'm not claiming to have it all figured out. I'm just throwing it out there because if you got really intelligent listeners, guys, get at me. My email is nathanppl@yahoo.com. I want to hear your thoughts and theories on what's going on with this because I don't claim to have all the answers, but I want to figure it out, at least what we can measure and test. And a moonlight is measurably cold. There's no explanation for it on the heliocentric model. That's why Red just denies it or, whatever.
Well, I think Red's is saying, and correct me if I'm wrong, Red's, there's just no such thing as cold light.
Yeah, because here's the thing. Being that I have the luxury of being on a computer, I'll go ahead and utilize such tools. A buddy of mine by the name of Astronomy Live actually did this observation to go ahead and figure out exactly, if there's any merit to this. And guess what? There simply isn't any merit to this. I will link his video in the description, or I should say I'm going to ask that you guys, the actual moderators and the owner of this channel, link his video in the description. And he does this observation, or I should say experiment, that the flat earthers have. There is no temperature difference, detectable difference, verifiable difference, or even everything that we were able to get on our thermometer was negligible. We're talking about like 0.2 to a 0.3 of a freaking degree here. So if you have something that's different than that, then please show it. But we will also let